Hello, and welcome to Lesson 12, where we will go from ratio tables to double number line diagrams. We will start with exercise 2 because exercise 1 was one that would be conducted in class and would need your classmates as well. But before we start with exercise 2, I would like to introduce you to the concept of the idea of a double number line diagram. Let's start with a word problem. A 12-ounce bottle of sport drink contains 21 grams of sugar. If Claudia wants the maximum number of grams of sugar she can drink to be 7 grams, how many ounces of the sport drink can she have? Okay, as with all word problems, we start by saying, what's going on here? What exactly is happening? So take a minute right now, and what is happening in this word problem? Okay, so next thing we need to do is find out what exactly do we need to find? What is the problem asking us to find? So we underline the question, which says how many ounces of a sport drink can she have? So that's what we need to find out. So she's drinking a sports drink, which could be Gatorade, it could be Powerade, something like that. We know that the 12-ounce bottle that she's drinking contains 21 grams of sugar. However, she wants the maximum number of grams of sugar that she drinks to only be 7. So she really shouldn't drink all this because she only wants the most 7 grams. She could have less than 7, but she doesn't want to go over 7. So how many ounces of this particular sports drink can she really have? That's to find out. So let's try this. Here I've drawn in 2 number lines already. The first number line represents ounces. The second number line represents grams. As you can see, a number line continues on and on. This one does as well as this one. We could put arrows over here as well. I just didn't happen to do that. So that's what those arrows mean. So my ounces, we saw that a 12-ounce bottle of sports drink contained 21 grams of sugar. So that was represented here. 12 ounces. At that same spot, there is 21 grams. So the second number line, representing grams, has my 21. Now, she only wants to max out at 7. So what I've done is I've drawn another one just before that. Well, way before that actually, because 7 is way down here. She only wants to have 7 grams, but we don't know how many ounces that will give us. So this is where my number diagram, my double number diagram kind of comes in. What I did was I said, what if I were to go back from 21 to 7? What exactly would I do to make that jump, to go from 21 to 7? I drew a line in the middle because I thought, if I was going from one way to another, I probably could put a 14 in here. So I could say 7, 14, 21. And so I've divided this area into 2 separate pieces. So if I did the same thing with my 12, and I went back 1 and then another one, where would that find me? What do you think this number would be going backwards? Well, if you thought backwards or forwards, you could have thought 4 goes here, and then 8 goes here. So we have 4, then 8, then 12, and these are going up in increments of 4. Whereas this one was going up in increments of 7. Notice that they're not going up the same. This one goes up by 7, and this one increases by 4, multiples of 4. So that's a general introduction to our number diagram, double number line diagrams. Let's try working on some of our stuff, and we'll come back to this. It'll make more sense a little bit later. So, back to our classwork. Exercise 2. The amount of sugary beverages Americans consume is a leading health concern. For a given brand of cola, a 12-ounce serving of cola contains about 40 grams of sugar. Complete the ratio table using the given ratio to find equivalent ratios. So, what do we need to do? What's this problem about? Well, the problem is about sugary beverages Americans consume, and they're particularly focusing on cola, which is a type of soda, You notice there's no name brand. They can't really mention name brands, but any cola that you drink has a lot of sugar in it, and it's definitely an issue. So this is a real life problem. Let's do what we need to do next. Our direction was to complete the ratio using the given ratios to find equivalent ratios. So our given ratio was 12 ounces of cola for 40 grams of sugar. Okay. Well, if we want to go backwards, when we're going backwards trying to create equivalent fractions, we use division. Let me show you what I mean. If I divide this ratio by this piece, both by the same number, which would be 2. Remember our constant C? It has to be divided by the same number. In this case, it has to be divided by 2. So 12 divided by 2 will give us 6. 40 divided by 2 gives us 20. And that's a good place to start. All right. Now without this, we'll put our 6 in here. And we'll put our 20 down here. Now to finish this ratio, if we started here and headed back that way, what would these two numbers be? Well, these two numbers would be 6, 12, and 18. And these numbers would be 20, 40, going up by 40s. The next number is 60. Right. So 18 ounces of cola will give you 60 grams of sugar. So keep that information in mind because we're going to use this table in our next few exercises. Okay, exercise 3. A 1 liter bottle of cola contains approximately 34 fluid ounces. How many grams of sugar would be in a 1 liter bottle of cola? Explain and show how you arrived at the solution. Alrighty, let's talk about what's going on here. This, as you can see, is a continuation of the problem we just had, where we talked about soda and sugar. Sorry, cola and sugar. So in this case, we have a 1 liter bottle. Now, a 1 liter bottle is different than ounces. So that's the first thing we need to keep in mind. But before we do that, let's make sure we know what we're trying to find. Let's underline what the question is asking us to find. How many grams of sugar would be in a 1 liter bottle of cola? Now, back to our problem at hand. These are ounces and this is a liter. The information they gave us, though, is that a 1 liter bottle of cola contains approximately 34 fluid ounces. So 1 liter equals 34 ounces. That's important information. So it should be easy. We just look at our table and see where 34 fits in. So have you come up with some ideas of what you can do? Well, you may have decided that you can actually extend this table. So try extending your table if you haven't done so already, and then tell me what numbers would fit inside there if we were to extend these tables. All right, extending the tables should have brought you the 6, the 12, the 18, and then if you continue with multiples of 6, you would have 24, and then the next multiple of 6 would be 30, and then the next multiple would be 36. Down below in sugar, it increases by multiples of 20. So 20, 40, 60, just like the 2 table, only with in the tens column. If you weren't sure about multiples, you could also have added to each one. 20 plus 20 is 40, 40 plus 20 is 60, 60 plus 20 is 80. That's what multiples are all about. So then you have 100 and 120. Okay, so where does 34 fit? 34 doesn't look like it fits on this table. But it does look like it could fit in between here. Somewhere in here. Between 30 and 36 could be 34. Absolutely, I agree with you. Problem is, it's a table. You can't just squeeze 34 in there. Besides, let me know, would 34 be closer to the 30 or the 36? And so would the grams that go along with 34, would that be closer to 100 or 120? Do you think your answer would be a whole number? Why or why not? Can you express your answer in a mixed number? Do you remember what a mixed number is? All right, well, let me show you what I've done and see if you can follow along. I have created a double number line, one that shows cola in ounces. Sorry, cola in ounces and sugar in grams. Okay? I took these same numbers that we had on the table and I put them in on the line. But between 30 and 36, I put 34. And what I did was I separated 36 into parts, equal parts. The equal parts that I separated them into were 1, 2, 3, 4, 5, and then 6. If we counted, it would have been 31, 32, 33. As you see, 34 fits there, 35, and then 36 goes here. So we were able to count them by ones. Now, if I did it for this one, I really wanted to mirror and do the same. So I cut these up into 5 equal parts as well, counted by ones to get to 36. Problem is, 100 to 120, you can't really count that way. You can't go 101, 102, 103, 104, 105, 106, because that's not 106. That's 120. Sounds complicated? Hang on. It's going to get bumpy, but we will get through this. Let's look at it as fractions. How far is 34 between 30 and 36? Well, we know that there are 1, 2, 3, 4, 5, 6 pieces. I think I said 5 earlier. There are 6 pieces. And 34 is at the 4th piece. So we know that 34 is 4/6 between 30 and 36. So it's 4/6. Now, as with all fractions, can we simplify this one? Can we reduce it? Can we divide the numerator and the denominator by the same number? Well, we can. We can divide it by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So we can say that 34 is 2/3 of the way between 30 and 36. Can we then say that this number is also 2/3 of the way between 100 and 120? Even though we can't count these to get to 120, we can still use them as a fraction. The fraction can still be used, and it's still the same fraction. What's different, though, is what this question mark will be. Okay, let me explain that a little bit clearer this way. Now, I just told you that 34 is 4/6, which is equal to 2/3 of the way between 30 and 36. We also said that the amount of sugar now is 4/6 or 2/3 of the way between 100 and 120. That's what the sugar is, okay? And the 34 would be the ounces. So these are true statements. So if we have some fractions and we say it's of the way, of is another way of saying multiplied by. So how would that look? Now we're working with fractions and some multiplication. Let me show you what that looks like now. Okay. If we say that the intervals here are going up by ones, because we counted 31, 32, 33, 34, right? How would these be? These would be by 20. Comes from 100 to 120. So we really have to break this up into 20 pieces. That's crazy. I'm not going to do that right now. So let's do it this way. 2/3, we're taking the 4/6, the sugar, and working with 2/3 instead. 2/3 of the way between 100 and 120 would be 2/3 of 20, because from between 100 to 120 is 20 20 paces. 20 steps, 20 pieces, however we want to look at it. From here to here is 20. So 2/3 of the way would be 2/3 of 20, which is what we have right here. Again, the 2/3 just comes from our 4/6. I'm just working with the simpler form. So the number we're looking for is 2/3 of 20, because it's not quite 20. If it was 20, it would be at the 120 mark. If we want 2/3 of this 20, so 2/3 of 20, we multiply it, because of means multiply, then this is how we set up multiplication. A whole number, we put the 1 underneath. I think you remember this from last year. And then we just multiply straight across. 2 times 20 is 40. 3 times 1 is 3. Remember that ultimately our fraction bar also means divided by. So if we need to know how many wholes there are, then we can do this. 40 divided by 3, and that would be 1. Sorry, I'm writing on the words. 1 times 3 is 3. 4, take away 3 is 1. Bring down the 0. What times 3 gives me close to 10? 3. And then that will leave us, that would be 9. And then we have 1/3 left. That's where the 3 and 1/3 comes from. This was an extra piece that we don't really need to worry about. Not so much. It's the same thing as this. So we have 13 and 1/3. That's how far it is. That's not the number though, because 13 would be way down here. We have to now take that number and add it to the 100 where we're at. We're at 100, and now we have to go 13 1/3 more steps to get to here. So 100 plus 13 1/3 will bring us to 113 1/3, and that's what our question mark is. This piece right here is 113 1/3 grams of sugar. And if you look at it, it makes sense. If we were to break up the 100 to the 120 into each individual piece, let's look at what that would be. Another way of looking at what we just did. What I've did is I've taken the 100 to 120 and the 6 individual pieces, and I've blown them up for us here. So here's what this number line looks like. 100 to 120. To get from 100 to 120 is 20. Okay, this is supposed to be 20. However, we can't just put 1 inside each of these boxes, because that will only give us 6. We can't even put 10 in each box, because that will give us 60. What can we put in each box that in the end will equal the 20 jumps that we need to have? You tell me. Well, we'll start off with 3. Put 3 in inside each box. And that will equal 3, 6, 9, 12, 15, 18. But that's not 20. We need it to be 20. Well, if we put 1/3 in each box, along with the 3, will that work? Okay, so sorry it's so sloppy. It's the best I can do for now. What I did was I have our 6 boxes, which represent our 6 spaces here. I took our 20 and I divided it up by the 6, 20 divided by 6, and I found 3, but then I still had 2 more wholes to deal with. So I took my whole numbers and I divided them up into 3 pieces, so that 1/3, 1/3, 1/3 equals one of those whole pieces. 1/3, 1/3, 1/3 equals another whole piece. So we have 3, 6, 9, 12, 15, 18. Watch this. 19, 2, 3, 20. And there's my 20. I had to figure out 20 steps to get from 100 to 120, and I only had 6 pieces to work with. I had to divide it all up into the 6 pieces here, because this one was divided up into 6 pieces. And so that's where I got the 3 1/3 for each piece. However, we went 1, 2, 3, 4 pieces. So if we did 1, 2, 3, 4 pieces right here, right here to there, it would be 3, 6, 9. Here's my 12. And then the 1/3. There's 13 and 1/3 left. That's where that answer came from. Hopefully that was a little bit clearer for you. This was the math behind it. Take a minute to review the math behind it. See if it will make sense for here. And then go ahead and move on. If you have any questions, write them down and make sure you tell me about them. If you look back here and you're wondering where this 2/6 came from, the 2/6 would be here if you were multiplying 4/6 by 20. And that's why they put that in here, because you might have that as part of the answer. And if you do want to simplify it to 13 1/3. Okay, exercise 4. A school cafeteria has a restriction on the amount of sugary drinks available to students. Drinks may not have more than 25 grams of sugar. Based on this restriction, what is the largest size cola in ounces the cafeteria can offer to students? So as always, what are we trying to figure out here? What's going on in this word problem? Okay, and then what is the problem asking us to find? Sure. The problem is asking us to find the largest size cola in ounces the cafeteria can offer to students. You all probably have drinks in your cafeteria, and they have sugar in it. So there's a restriction of how much sugar can actually go inside your drinks. How do we figure this out? Well, let's start by drawing our double number line. Go ahead and take a minute, if you haven't done so already, and draw this either on your Word document or on your paper. Okay, so what we have here are the same numbers we've been working with today in this lesson. We have 6 ounces for 20 grams of sugar, 12 ounces for 40 grams of sugar, 18 ounces for 60 grams of sugar, and we could continue on. In the past, we've had more than this on our, but we don't need to, because we're only going to 25 grams of sugar. So as you can see, I've drawn in some extra lines here already so that I can put my 25 really right here. So why did I draw these lines in? Well, I drew these lines in because I needed to place 25 grams of sugar on here. And to do that, it's easiest to do it by counting in increments of 25. So if I do increments of 25, then between each one of these lines is 5. 20, 25, 30, 35, 40. So that's just why I made these lines the way they are. So one of the things I need to do is put my 25 in here. And remember that this will be my ratio. I don't know what it is though. Now I need to know how far from here it is to here. Well, I know that if I jump from here to here, I jump by 20s. And that's called a scale. When you go from here to here, whatever your increments are is also called a scale, how much I'm counting by. So if this is 20 to 25, this place here is 5. And then each one of these are actually in 5. If you count the pieces, each one of these are actually in 5 as well. But if we count the pieces, it is 1, 2, 3, 4 pieces. This is 1/4 over here. Okay? So if we've determined that this is 1/4 between 20 and 40, how far is this one? Well, it's also 1/4. If you remember before, what we did was we said that this is 1/4. But what's the scale from 6 to 12? What's the interval? How do we get from 6 to 12? We got there by counting by sixes. Here we counted by 20s. So by counting by sixes, we have to say that it's 1/4 of that 6, because it's not quite 6. So now we have our multiplication. It's 1/4 of 6. Here's what I figured out. I'm going to need to find 1/4 of this 6, and then I need to add it to this 6. So we know what we're doing. This is, if we were writing and solve what we needed to do, this is what we need to do. This is the words that we need to work on. This is the L part of solve. Okay, so how do I find 1/4 of 6? That's one that you already know. You multiply 1/4 times 6. Remember, 6 was 6 because of the increments, and the way that we do that is we put a 1 under the 6 because it was a whole number, and then we multiply across. It equals 1 times 6 is 6. 4 times 1 is 4. If we divide the numerator and the denominator by 2, it equals 6 divided by 2 is 3. 4 divided by 2 is 2. We go even further. That's 1 and 1/2. So, what's 1/4 of 6? Well, that's 1 1/2. If we were to take this 6 to 12 and break it up into 4 pieces, we would have 1 1/2 inside each piece. This is the first piece, so it's 1 1/2. So how much is it now from here to here? Well, that's why we're adding it to the 6. It is 6 from here to here, and then 1 1/2 here. So 6 plus 1 1/2 equals 7 1/2. Okay, so Chantel solves 3 math problems in 4 minutes. Use this information to complete the table below. Well, take a minute and do that yourself, and then write the numbers down in your answer on the puzzle, and then come back to the video. And here's what your table should look like now. 3 minutes, 3 questions in 4 minutes. Okay. All right, part B. Chantel has soccer practice on Thursday evening. She has a half hour before practice to work on her math homework and to talk to her friends. She has 20 math skill work questions for homework, and she wants to complete them before talking with her friends. How many minutes will Chantel have left after completing her math homework to talk to her friends? Use a double number line diagram to support your answer and show all work. So, first thing, what's going on in this problem? And what is the problem asking us to find? The problem's asking us to find the number of minutes that Chantel will have left after completing her math homework to talk to her friends. So that's important. What I've done here is I've made a copy of the ratio table that we just came up with in the previous problem, and we're going to use that now to create a double number diagram. So go ahead and do a double number diagram. See if you can't figure out the answer based on all the work we've done today so far. And then come back. Remember, you must answer the question. Don't just do the double number diagram, figure out where it goes, and then not go back and answer the question. Okay, so here's the double number diagram that I have, and it is the same one that you see up here, up to 21. And I didn't bother putting those in because we know that she has 20 math skills questions. So she has 20 questions to work on. So she's going to be right in between here somewhere. Right in between here is where we want it to be. And so that's why we only went to 21. Here's where she has 20. So what I did was I went ahead and said from 18 to 21, that's the information that we have, there are increments of 3. So I broke this up into 1, 2, 3 parts. Of course, I needed to break this up into 3 parts as well. How much is the 20? Well, the 20 is 2 of those 3 parts. That's where I got 2/3 from. But what's the scale from 24 to 28? What are the increments? Well, that's 4, not 3. 4. But it's still, this part is still 2/3 of that 4. That's where this 4 comes from. So 2/3 of this increment of 4 will be exactly how much from here to here. It's not 4. 4 would be right here. It's just 2/3 of that. And the thirds are because you bring this down here, you bring this down here. We've broken it up into 3 parts. So 2/3 of 4 is 2 times 4 is 8. 3 times the 1 is 3. That's 8/3. 8/3, when you divide 8 divided by 3, will give you 2 with 2 left over, so it comes out to 2 2/3. But we're not done. This is just 2 2/3 from here to here. From here to here is the 24 plus those 2/3. So that's where I got 24 plus 2/3, and that's 26 2/3. But that's not my answer. This is 26 2/3 here. Okay, when she to complete 20 questions, it will take her 26 2/3 of a minute, or 26 2/3 minutes. However, the question said, how many minutes will Chantel have left after completing her math homework to talk to her friends? Well, if you go back to the beginning, it says she has a half an hour before practice to work on her math. So that's 30 minutes. And that's where this 30 comes from. We take 30 minutes, we subtract 2 2/3, and you should have 3 1/3 minutes. So Chantel can talk to her friends for 3 1/3 minutes. How did we do? Did you understand all this? Do you have any questions right now? Did you get to step 3? Give me some feedback. Okay, let's see what we learned today. Name 3 different ways now that you have learned that you can represent a group of equivalent ratios. Today we just learned about 1. Well, you learned about a ratio table, you've learned tape diagrams, and now you've learned about double number line diagrams. Okay, share 2 things you learned about double number line diagrams today. Okay, tell 1 thing you want to know more about from today's lesson. Something that was confusing or something that you just like to know a little more about. Well, in today's lesson, you learned a double number line is a representation of a ratio relationship using a pair of parallel number lines. One number line is drawn above the other so that the zeros of each number line are aligned directly with each other. That means they're right on top of each other. Each ratio in a relationship is represented on the double number line by always plotting the first entry of the ratio on one of the number lines and plotting the second entry on the other number line so that the second entry is aligned with the first entry, one right above the other. And that's basically what we learned today. Here's your exit ticket. Kara is participating in a fundraiser walkathon. She walks 2 miles in 30 minutes. If she continues to walk at the same rate, determine how many minutes it will take her to walk 7 miles. Use a double number line diagram to support your answer. Remember, on Edpuzzle, you only have to give an answer, but I'll want to see the work as well.